Yeah, so we decided to kind of try something different. I was an academic for many years, and so I was kind of surprised when I came to the legal world, and like every single presentation at every conference is a panel. And different fields have their own kind of stereotypical ways of running sessions and whatnot. So we decided to shake it up. Mark is an old friend. Every time we get together, we have fantastic conversations. And what we decided to do is just like let you listen in on one of our conversations. So I'll introduce Mark. He's the Director of Technology Assisted Review and Analytics at Hogan's Level, but he's had a variety of positions in e-discovery and investigation over the years. Mark impresses the hell out of me because one, he's a former sheriff, and two, he has a degree in physics. And like, how cool is that, right? I mean, so there you go.
It's a weird resume.
Yeah.
But I also enjoy the conversations because having the PhD and the lead research scientist, it gives me an idea of what's possible. We take practical problems that we get from clients in the trenches and say, can I possibly do this, or can I do this, or if my statistics are wrong, he'll let me know about that sort of thing. So I always find these conversations really helpful too, because I get an idea of what's possible from the information retrieval or computer science world. So what we're going to do is start going into some of the investigations topics that we've been working on here recently.
And all of you are welcome to join the conversation as well. It makes it much more interesting for us. So it was interesting. It was kind of observed from the audience that maybe this is the year where investigation kind of takes over from e-discovery on the whole kind of legal tech circuit. It's definitely some kind of phase change here, where there's just intense interest in this is the kind of hot application area for artificial intelligence. However, there is a little ground setting that I'd like to do about technology-assisted review, just because part of how we thought we wanted to structure this conversation is how are investigations different from doing e-discovery in, say, a large litigation or an antitrust investigation or something like that. So since we want to play off against the differences, I want to sort of level set to make sure that people have at least a little sense of what we're talking about when we talk about technology-assisted review. So the real nutshell sort of idea here is you're in a litigation, you've got a ton of documents that you potentially need to go through, you've gotten a request for production from the other side, the request for production from the other side is always overbroad and whatnot, and so you got to go through millions of documents. You can't afford to do that anymore, you can't afford to have lawyers look at it. In about 2005 or so, people began to look at what in computer science would be called text classification, and in particular supervised machine learning for text classification. And all that means is teaching the software by example. Here's a document that should be produced, here's a document that shouldn't be produced. This technology's moved quite a ways in the past 15 years, both drawing on a much longer history of supervised learning. One thing I like to point out is that continuous active learning was actually invented in 1965 and was called relevance feedback in computer science. So you can call it TAR 1 or 2 or 3 or 17 or whatnot, but it's actually been 11-teen, there you go. But it's actually been around almost the entire time that I've been alive, and I'm getting pretty old now. So that's in a nutshell it. You train a system by example to recognize the stuff that needs to be produced. You maybe have, say, 5 million documents, and you expect that 100,000 are going to be relevant. You don't want to look at 5 million to find those 100,000. Maybe what you end up doing is you end up looking at 500,000 and finding 80% of the 100,000 that you would have gotten in theory if you had perfect human beings looking at the 5 million. So that's just that's going to be my incredibly oversimplified view of stereotypical technology-assisted review in civil litigation. So what we want to talk about here is how are investigations different? What are the implications of that for the use of artificial intelligence technology? What are some of the kinds of technologies that are out there already? And then if we've got time at the end, then we'll speculate a lot, as we often do when we're sitting over coffee, about what's going to come next. Okay.
Yeah, so also one of the things that's different about investigations is it's not really a recall-based search. I mean, you mentioned that the term of art is classifier for text classification. And so when you're responding to a review for production, you've got a couple of things. One is that the information need is pretty well defined. You've got an RFP. And also you have to produce all or substantially all of those documents. When we're doing an investigation, though, this gets back to some of the stuff that the panelists talked about earlier today, which is what's the narrative, what's the story in these documents? And so often that's much more of a relevant search. I don't want all the stuff, all the documents related to what went on. I want to see what tells me the stories that I need to know as quickly as possible. So fundamentally, that's a different type of search, but we've also found that a lot of the predictive coding, TAR, supervised machine learning tools that we've been using for classification tasks also can be adapted to investigations pretty effectively.
So in an investigation, I mean, I presume that when you do produce the results of the investigation, you'll need some sort of backup, right? That is, you don't just get to say person X did Y. You actually have to show some of the documents, but do you show just the best? Do you just need one or two? If there's, like, maybe there's 100 documents out there that say that X did Y, you know, are you done when you find like the first one or two, if they're good enough?
Yeah, and that gets to the lawyer's answer of it depends.
Okay.
Right? The real trick, I think, is topical completeness.
Okay.
Right? You need to know what else could be dug up out of this set. And we've talked about this before. It's like the minimum spanning tree problem before, which is like, I've got this big pile of documents, like 5 million that we just had to produce to the government, and now I need to know what's in there before they get a chance to review it. So if there's something bad, I can get ahead of it. I have time to review 500 documents. What 500 out of this set will give me the most accurate picture of all the topics or all the potential stories that are in this?
So do you know all the topics in advance, or does that change?
Oh, no. Yeah, and that gets back to the thing we've also talked about with investigations is it's kind of defined by an evolving information need, right? You know, you don't have a request for production. Instead, you're looking for stuff that's unusual. And unusual can take lots of different forms. And one characteristic of investigations is often your theory of the case, your idea of what's important changes as you go through it. You find something new, which you thought was, you know, this is one of the case studies I think we've talked about before. Something that you think is an employment matter all of a sudden turns into sort of a financial or embezzlement matter because you unearth something while you're doing one type of investigation. So these things can often take some unexpected turns really quickly that you have to adapt to.
So then, you know, in a kind of classic TAR situation, you might be training, you know, iteratively hundreds of examples, maybe even a few thousand examples for a single topic. Is that going to be something you're ever going to do in an investigation then?
Yeah, probably not, because again, it's more of a knowledge generation task, right? It's the kind of search that's less like a review for production, more like a Google search. You want to, what's relevant? You know, give me the most relevant document for each topic that's in here, or each incident, or each thing that went on, so that I can quickly find out what all the stories are, and what all the stories are that opposing counsel might tell. And, you know, and then I can get a handle on what this document set could mean for the client. You know, I don't have to have 14 copies of the same thing establishing that this guy, you know, was embezzling money or something like that. But on the other hand, if you have a suspicion that something's going on and you're not finding any of those documents,
we'll come back to the not finding any.
Yeah.
But the issue of kind of the set of topics you're interested in potentially changing rapidly, you know, means you can't sort of invest a huge amount in one topic. You kind of need really rapid effectiveness from the technology with minimal investment. So, you know, so we've talked about, you know, in some sense, search was the original AI technology for doing that. I mean, you literally just sort of type the words out, you know, they come out of your head, and you get something back immediately. Now, it's not getting back results that are as accurate as if you've done a ton of training or something, but, search technology has kind of a 60-year history, and it's gotten better and better. But I think the interesting question is sort of what can you still do with supervised learning? And, one of the things that we've done in BrainSpace is let you insert domain knowledge into supervised learning. So you can kick off a supervised learning session with a predictive model that is just a CSV file with a bunch of good terms. I mean, much like a search, except that you now use that as a starting point, whereas if you do have time to label a few training examples, you can do that.
Yeah, so essentially your previous TAR model is the term that you're using to search upon.
Well, yes and no, it might be hand-created.
Right,
but
you could edit that CSV file.
Right, but you bring up another possibility too, which is, the cross matter.
Right.
So that even though it's not worth putting a ton of effort into a single matter, if you've got topics that recur, sexual harassment, angry language in emails, references to money troubles and things like that, you potentially can build up by supervised learning models over a bunch of cases. You're not, you're not labeling 1,000 examples on one case, but by carrying these topical models, a kind of library of them across from case to case, you can amortize across cases rather than amortizing within a case.
Right, yeah, and even if you're not using BrainSpace and portable classifiers.
Which would be so sad.
Yeah, it would. But I've done the similar things in the past where, for example, there was a shareholder lawsuit, but there had been an SEC investigation into the same matter. And what the SEC was asking about was very similar to what the RFP was in the shareholder suit. So we can take 40,000 or so reviewed documents from the first matter and use those to train up a TAR engine to immediately start finding the important stuff for a second one. That's an example of reusing work product for a classification task, a review for production. But we can also do the same thing to look for certain types of fraud or certain types of things that you might run across in an investigation. Because I had a client who we taught their internal audit team to use BrainSpace, and they picked it up very quickly because they like the UI.
Cool.
He likes this story because they didn't like relativity at all. They love BrainSpace.
Wonderful story, Mark.
Yes. But they also, when they were going through all of these emails looking for potential FCPA violations, they usually had about 24 different theories of the case that they were looking for, 24 or so different types of fraud or malfeasance that they usually run across in the past. So that's not exactly an easy thing to code for. But if you've got examples from other documents or other projects that they've run in the past that get encoded in as either you set those positive training documents aside to use them as training documents on the new project, or the easier way now is to just export that machine learning model and then load it back up again when the new stuff comes in and see what's most like this type of embezzlement or most like this type of fraud involving purchase orders or something like that.
So I've talked to BrainSpace before about this. So that ultimately is not client-specific in any way. That's a generic model that you could apply to different types of...
Well, that's something that the user's going to have to vet. And this is why when we introduce the portable models, we introduce portable models rather than portable training sets. Because there's often, almost always sensitivity about moving data from one case to another. But by exporting a model, it's basically just a list of terms and weights. You can look at that and say, oh, you know what, that's kind of, secret code word within this company. We really don't want to export that. We'll export the rest of the model, but not that.
So hypothetically, you as BrainSpace build up a library of portable models.
Well, no, our clients do.
Or the clients.
So the whole point of the software is it's letting our clients develop IP that they reuse from case to case. So like if you're a consulting firm, you can build up a set of specialized models that you apply in all your applications. We, at least to date, we're not rolling out any portable models ourselves. We may do that in the future in fact, that's one of the strategies we may use for sentiment analysis in the future.
Right. So and sentiment analysis is where I was going, but also the risk question then that you would have if you did that. Like, here's a model, go use it, and then some complications about it.
Well, yeah. I mean, there's a risk in using machine learning ever. I presume that if we roll out our own portable models, they'll come with some
The
appropriate
lawyers,
language or something.
disclaimers, yeah.
We're part of Sixtera now, which is a big cybersecurity company. They have lots of lawyers and things. I'm sure that they'll figure out.
Yeah, but I think there's also something I remember having discussed this with Jeremy Pickens a while back also, and that is sometimes this can be an empirical question. I mean, is making something that's very specific to a domain actually useful or not? And find that there, with machine learning and these types of models, our intuition isn't always a really good predictor of what's actually going to be effective and what isn't. So sometimes we actually just have to run the experiment and see whether a generic classifier or one that is specific to an industry, specific to pharmaceuticals, specific to ANDA, specific to whatever, is because one of the things that we run into with the training is the network effect of training, right? The idea that the reason that there's only one internet is Metcalfe's law. The value is in all the interconnections, and the interconnections grow as the square of the number of nodes. Like the square of the number of documents gives you all the potential interconnections among them. So if you take all of your case data on privilege and put it together into one privilege classifier, and then you pull out the client, the client-specific stuff, like particular
The
names.
stuff that's gonna screw up the model.
Right, the stuff, or stuff that you can eyeball and know is only specific to one client. But then you've got all of this training data for privilege. Is that going to outperform something where you train a model on privilege just for pharmaceutical companies, and then on privilege just for the IP litigation, and privilege just for the E&L stuff? Because each of these training sets is much smaller, and by pooling them together, the training value grows as the square of the number of documents in there. So there's benefit to pooling that data together to train the model, even if you lose some precision, because there might be something that's domain specific.
So we've been very interested in this exact thing, precision and privilege model analysis.
Yes.
That's all we can say about that. But,
Okay, yeah.
So this is ultimately not the big red button that you push, and all privilege reviews now take 10 seconds, right?
No, I don't think we're there yet. No, but I mean, it's that we've got a number of clients who are using it for privilege review, or at least experimenting with it. I don't know if it's in their regular workflows now. It certainly helped a lot when we introduced the metadata support for supervising. Yeah.
How do you mitigate the risk, though, of a less sophisticated entity thinking it is the easy button? And the way I look at it, this is a starting point that allows you to kind of have a leg up from starting at zero. But there will still be people who are less sophisticated and thinks, all right, I press this button and I do a little bit of coding and suddenly it's totally defensible. Sort of how are you mitigating that? Is it through training? Is it through kind of guiding them through the process?
Well, yeah, it's interesting. I guess the first thing I always say at the beginning of every time I get asked about this is defensibility is a legal question. It's not a technical one. But the second thing I would say is if you're using the model for a prioritized workflow, that itself is, in some sense, you can never get in trouble because it's just a question of everything. You'll find everything relevant if you go far enough. It's a question of how much money you're saving, and that's the thing that I always. This is sort of getting more into litigation issues than investigation because, how much data you have to go through says how much training is worth doing. Right? If you've only got 10,000 documents in your collection, it's not worth doing a lot of training. If you have 10 million, it's worth doing a lot.
So does cost-benefit analysis help the model, or does it undermine the model?
Well, no, cost-benefit analysis is providing guidance to you as a manager on things like how much training is worth doing. Right? I mean, that's
and so my question still stands. Does that help the model?
Yeah, the model.
Yeah.
All right. So I want to return to, you brought up one of the big points we wanted to talk about, which is a big difference between investigation and a litigation situation is what if there's nothing? Right. You're looking for topic X and there is literally nothing on topic X.
Yeah.
So what do you?
And you have to convince the government regulators that, no, we really did do a thorough diligence search and there was nothing like what you were asking for. Right? And how do you demonstrate that?
Yeah.
So
Yeah.
this is one of the places where we found that some of the e-discovery, like classification tools, like using TAR, can be part of your toolkit there, because the general approach that I've used in this is that you want to use every possible technique that you can think of. So you've got a qualitative argument to make to the requesting agency or whoever it is that said, look, okay, so we used your search terms, and then we used our search terms, and then we ran both of those search terms through query expansion to see if there was anything else in there that we didn't know about that we were using. We went through the clustering tool. We used the supervised machine learning model. That didn't turn up anything, so then we started taking this effect that the supervised learning can train on close but not quite documents. And then we started training it up on borderline stuff, or on your idea of the conjunctive training. And so we try these techniques to see if we can smoke out any relevant documents, and then maybe at the very end we pull a random sample just so anything has got an equal chance of getting surfaced by the time we get done.
I think these are worth kind of diagramming, right? So, because the thought is, supervised learning, the idea is you train for positive examples and negative examples. But we just posited there are no positive examples. Not only do you not have any positive examples in hand, no matter how much work you do, there will never be positive examples, right? John did not rip off the company. So how do you go about using supervised learning in that? So Mark talked about one method, which is you train on, instead of training on yes versus no, you kind of train on near misses versus stuff that's just really not relevant, right? So this is the thing you're looking for, and you can't train on this versus everything else. But what you can try to do is you can sort of try to, draw a ball around what the interesting relevant documents would be. You train on the stuff that's in here versus the stuff that's out there, and then you see if there's anything left in there. Does anything get a high score? So you don't have anything that says John, where John's talking about fooling with the purchase orders or something, but you've got Mary fooling with the purchase orders, and you've got, John talking about something else that's vaguely financially related, and, whatever. You have your kind of near misses, and then eventually you sort of do some training, and then even there's nothing that even scores high for being a near miss. So that's kind of one approach. So that's, I guess we'd sort of call it the kind of near miss approach. And then the conjunctive one that Mark mentioned is, so suppose you can define the thing you're looking for as an and of two or more ideas. So you're looking for...
John had unauthorized access to financial data, and John made money transfers.
Right, and so
Something
that
like
the
that,
ideal
yes.
relevant document would both be a money transfer, and that's a little hard. That's a little harder to search for, but something like that. You've got
A and B.
It has to be
elements.
both. Let's see, angry messages that are talking about money, right?
Okay.
So let's say you can't find any angry messages that are talking about money, but you can find angry messages. So you kind of train an anger classifier, and you train a money classifier. Right? And you can find some positive examples for each of those. And then you look at the things that score high on both. Right? So you've done supervised learning, you've trained each of these, and then maybe you find something that scores high in both, even though you didn't have any of those to start with. So these are the couple of the methods we've seen used in this kind of investigation context. Yeah, David.
What about just creating a fake document that was looking for?
That's on our list.
Then the synthetic seed, right?
And the synthetic training examples is another one. Yep.
Yeah, in fact, we had an interesting conversation about that a week or so ago, because we were talking about reusing work product or an interface for lawyers, and I think your question was, well, why don't you just put a portable classifier in and look for that? You can just write up the terms and the weights. And my response is that if I give that to the average lawyer, they would have no idea what to do and they would be bugging me. But if I tell a lawyer to write a document, that's something they know how to do. I say, give me what you think a smoking gun looks like in 3 pages or less. And they don't require any other intervention. They know exactly what to do. So the lawyers can generate those synthetic seed documents much more easily. So it's actually a pretty good interface for practitioners, because they don't have to learn anything about terms or weights or anything like that. Just give me what you think a smoking gun looks like, and we'll see what comes up near it. But absolutely, and then back at that, back to the negative zero results thing, is that we tried that. You know, we tried the smoking gun. We even asked you, investigating agency, to give us what you think a smoking gun would look like, and we could do a search based on that. Anything that you give us, nothing turned up. You know, so now, you know, basically the story is that we reviewed 7,000 documents across this, however many different techniques, nothing came up. If there was something to be found, it had every opportunity to be surfaced in this. And so that's what the defensibility story looks like, you know, when you've got an investigation that doesn't have any positive results to it.
So that issue, when you're writing a report like that, that sort of defends or makes the case that there was a negative result, do you develop kind of standard procedures in advance? So you do that same way every time, or is it kind of case specific?
Yeah, it's usually case specific, but the general rule is that you throw a bit of every technique that you can at it, because part of your argument is that we used 8 separate techniques to search this document set, and here's what they are: bam, 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 bam. None of these came up with anything, and 3 of these techniques used stuff that the opposing side provided or had input on. So we did everything that was reasonably possible and gave, if there were any positive documents to be found, we gave them every possible opportunity to get surfaced, and yet they didn't. You know, there's also,
I think when you talked about opposing side, though, what is there a need to justify the negative results if it's, say, just purely an internal investigation?
well, if it's an internal investigation, then it's often just a matter of what comfort level do they need. And then that gets back to the idea of the cost-benefit analysis. How certain do you need to be that you've mitigated the risk, or that you're comfortable nothing is in there? And a lot of times it'll depend on what the violation is, whether they've got a good reason to believe that it actually happened, or whether they're just doing a more routine check, or they heard as somebody said earlier, a whisper, about it. So often these things come with these cost-benefit analyses, and you talk to the client and say, okay, well, what makes you think that there's something in here that you need to know about? And if there is something in here, what's your exposure? So is it the kind of thing that you want to spend $10,000 reviewing, or something that you want to spend $500,000 reviewing? So, that often makes a big difference.
So I'm curious about both your thoughts on that particular issue, about how you know when you're done. And, from as e-discovery practitioners or just people in the field, we know, okay, well, from a risk perspective, we don't want to say, yes, you're done, absolutely.
Mm-hmm.
It's great, everything's fine, you can stop. That's more of a legal question, and you can kind of address that with a cost-benefit analysis, how many dollars to the next document, recall testing. But then from the tool side, or from the technology side, is there some kind of nudge that we can provide, or that you can provide, that doesn't really cross the line to giving assurance that there is nothing else, but that gives people comfort that we have reached a certain level, and I'm thinking providing recall numbers, and those techniques all exist, but they don't seem to provide a psychological kind of nudge to that point where you can say, I'm done, I'm good.
Yeah, and I think the approach of using multiple techniques, like you use even in a 0 positive results thing, helps, because we're all kind of inner Bayesians, right? If we used clustering and we didn't find anything, if we used the search terms and query expansion, we didn't find anything. If we, or we only find a few things using clustering, and then that technique is exhausted. We run our search terms, we run search term expansion, we find a few more things, but then that term's exhausted. So we figure, well, okay, if we just did the searches, maybe we were done, maybe we weren't. But if we use 3 or 4 different techniques and we exhaust them all, then the odds are getting better. We may not be able to quantify them, but the odds are getting better that we're going to be comfortable with that result, because we've attacked the document set of the problem from like 4 different angles and kept at it until our yield was going down. We were finding new stuff. And I think a lot of times for practitioners, that's easier for them to accept, right? Because they don't have to trust one technique or one black box. They say, well, we did this, we found a few things, but then it dried up. And then we did this, found a few things, and so forth.
Yeah, and I think the advantage of that approach is, unlike a recall estimate, you don't run into the richness problem. I mean, the problem with recall estimates is the size of the sample you need to get a decent recall estimate goes up the lower the richness is. And at some point, it becomes economically impractical to get high precision recall estimates. And so I think that's why these things like, looking at diminishing yield, looking at the fact that you've tried a number of different techniques. Another one you can do is if we use logistic regression in our system, so it means the scores with a lot of training. I'll wrap a lot of caveats, but with a lot of training data, the scores are calibrated. That is, a score of 0.8 means there's an 80% probability the document's relevant, roughly speaking. And so at some point, if you have no documents that have a high predicted probability of being relevant, that's another sort of signal there. But what I always encourage, and this comes up mostly in sort of, I won't quite accept the sort of TAR 1, 2, 3 sort of presentation we had earlier, but in next generation TAR approaches where you're not using a large random sample to get a recall estimate, we get a lot of requests for how do we know when we're done, and say, well, it's this multifactorial thing, and then also was brought up either it's a cost benefit thing. If you're using a culling classifier on a very large collection, you want a better model than if you're using on a small collection. If there's more at stake in the case, then you want to go farther than you would go if there's less at stake in the case. So these are things that any review manager is going to be thinking about anyway.
So what do you think about putting some kind of a, what you both just described, putting some kind of a framework or standard, well, I won't say standard, but some kind of
Sufficiency.
Yeah, something around this.
Score.
Right, and maybe not necessarily a number or specific,
Yeah.
but a methodology where, because my experience is that sometimes the work just expands to fill the time allotted or the
Yeah.
budget.
Sure, it's a danger.
And
Yeah.
that's how,
And-
that's really the factor is like how much time or money do we have left, rather than.
Right, and well, one example that I'm dealing with a lot right now are second requests. Right, so if you're using TAR to reduce the population that you're going to produce, with the DOJ rules, they don't want you to review the entire thing once the classifier's in shape. So you're going to be kicking a lot of stuff out the door, but you still have to do privilege screening and QC and logging. So if the production has more non-relevant stuff in it than it needs to be, then your priv review and your priv logging is going to be more expensive. So in those cases, it's probably worth doing some training, especially if you're looking at a 10 or 20 million document set, to make that production more precise, so that you're not only reducing your costs for priv review and logging, but also reducing the risk that you're producing something that you shouldn't. And that's also kind of hard to quantify, but a lot of times that's something that you have to talk over with the case team and say, well, look, it's probably, in this case, given the size of this and how risk tolerant the client is and how, and we're finding 3 or 4% privileged documents in this case, this is probably where the sweet spot is going to be. But a lot of that gets back to that lawyer's answer of it depends. You've got to sort of see what all the factors are that are in play and also which ones are actually important to the client.
So we have a question back there?
Yeah, just a question on timing, when you actually begin, starting seed sets, starting to teach, the computer. Really common internal investigations have a problem that kicks off the case, right? So say just, for example, drawn from hypothetical facts. We've got a suspected FCPA problem, right? So you start looking at your FCPA problem, you quickly realize, well, actually we've got a UK anti-bribery problem too. Okay, now we've got a GDPR problem. And then, 3 or 4 weeks later, now we've got an OFAC trade sanctions problem, right? I mean, this happens, right?
Yeah.
So, I mean, I can tell you, I don't want to go back to my client 4 times and say, well, we ran a seed on the FCPA stuff, got our training set, 30 days ago. Now we need to go back and start again with all the data and actually factor in, the new problem, the problem that the problem has, right? When do you start?
Well, I mean, I think, one of the things that we've tried to do at BrainSpace is just kind of really bring down the barrier for that. So it's I mean, you can train a predictive model on one example. So it doesn't have to be a super heavyweight thing. Now, if you need to go to an external firm to get an expert on it, well, in some sense, if the overhead is bothering the firm and asking for their time, then it doesn't really matter if it's one example or 50, but it's better than it being like, 10 rounds of 200, right? So that's part of it. The other piece is then, well, if it is an issue where you really sort of want to hold off, well, you can hold off on, and there's really nobody internally who can train. And I think one thing I would stress is, because that we and other firms as well, have brought down the overhead of building predictive models to where it's really no harder than building searches. There's not a lot lost by, say, somebody from your firm, even if they're not an expert, building an initial predictive model and seeing what you can do. And maybe eventually, to do a really good job, you need to go to an outside expert and you say, okay, sorry, we got to make the phone call. Yes, we're coming back to you for the fourth time. But, we already found this good stuff. Aren't you really excited? And could you help us a little more? So I think that's some of how you can approach that.
Yeah, and I think some of that also gets to this idea of how do you get topical completeness really quickly, right? And there are lots of different ways that we go about that. One that we also have co-opted from technology assisted review for classification is diversity sampling. So one way that you train a classifier, like you said, was relevance feedback, the most likely to be relevant document, because relevant documents are better for training than non-relevant ones. There's also uncertainty feedback, which this guy has some quite a background in, which is where you give the machine the documents that it's most uncertain about how to classify, so it learns the most from getting human decisions on those. Diversity sampling is more like explicitly modeling the unknown, looking for pockets of stuff that's different, doesn't have any human decisions on it. And so when you use that, instead of just to train your classifier for production, but you use that in itself as a way of sampling all the unreviewed documents to get representatives of the different stuff out there, especially things that you might not know to search for. And this gets into some of the stuff we've talked about adversarial search, right? Somebody's using code words, somebody's using obfuscated language. You may not have any idea how to search on that, but the exploration tools that you want to use are going to be things like your clustering and looking at centroids at the clusters, or looking at the cluster wheel and brain space, where we often have investigators just open that thing and just scroll through and look at all the words and phrases that describe each cluster and see if anything jumps out at them. Our classic story from that is the Pink Floyd story from a few months ago.
Yeah, which is sort of like, the issue being, if somebody has obfuscated the data, so they've gone in, they've used a code word, conceivably, I guess they could even have edited documents if you didn't catch that. One of the things that helps with that is, no word is an island, right? I mean, they may have, the tobacco companies classically, used Zephyr instead of cancer and things like that. But, I think as we talked about, the relationships are what brings that up. So you brought up, well, tell them about the Pink Floyd one, right?
Yeah, so that was an investigator scrolling through the cluster wheel and brain space, and they were looking through like financial stuff and purchase orders, and then there's a subcluster about Pink Floyd. So why is classic rock part of financial data?
Yeah.
Well, that was the code word that they were using. That's why. So often, and this gets back to the theme in the title of augmented intelligence, is that the human practitioners have got the ability to spot what's important. And so a lot of times what these tools, the exploratory tools like the clustering and the diversity sampling, is just trying to let the machine figure out what is unusual and worthy of the investigator's attention. But then the investigator looks and says, wait, that shouldn't be here. Or why is this person talking to this person at 2 in the morning? Why are they talking at 2 in the morning? Why do they always talk to each other in big long paragraphs, except for this week where they just send messages and say, call me. So you're trying to find, the unusual stuff and bring it to the attention of the human practitioner, because the machine can't tell what's important. It can just tell what's different or unusual or unseen. But often presenting that to the investigators helps them find, the important stuff quickly.
Yeah, I think that's kind of the key thing. The statistical tests and really all of artificial intelligence these days is mostly boiling down to fancy statistics. You could detect relationships, but you can't. But the software does not have the knowledge of which relationships are important. The investigator has the knowledge of which relationships are important. So, one thing you can do is detect a whole bunch of relationships and use a powerful graphical interface that throws a bunch of them up there so the investigator can look at a lot of them quickly and spot which ones are interesting. Another one is to guide the relationship, guide the unsupervised structure finding by the investigator's knowledge. And so, in BrainSpace, for instance, you could do a search, any kind of search on a set of documents and apply unsupervised learning just to that set of documents. And so you've focused in on a set of documents where there's likely to be unsupervised, likely to be interesting relationships, and saying, okay, just go find the interesting relationships here. Because you were mentioning the n squared thing. The n squared thing works against you too, right? The more documents there are, the more possible relationships there are to find, which means the more opportunity for false positives in any statistical model.
Right.
The more terms there are, the more possible relationships there are between terms, and the more false positives that an unsupervised learning method can
Or put another way, on a sufficiently large data set, you could run 1,000 different clustering algorithms and get 1,000 different clusters.
Well, you will. Yeah.
Right, yeah, because there are lots of different
Actually,
ways.
we don't like to say that one, actually. Edit the tape there.
Yeah, well,
But
I'm
ours is
not
best.
a vendor, so I'm allowed to say that. But it's also one of the caveats that we give to attorneys is that different clustering algorithms will do things differently. We use the example of we've got shipping going back and forth between New York and London, and some of it's going by air and some of it's going by sea. You give it to a clustering algorithm, is it going to say, well, there's U.S. English and there's British English, so I'm going to cluster it this way? Or is it going to say the terminology from air freight and from ship cargo is very different, so I'm going to cluster it this way? And it may even be that there are different carriers and you're only interested in the stuff that's coming through one carrier. There are lots of different ways that you can cluster even a simple set of facts like that. But it still helps as an exploratory tool if that's your first, if you've got 5 million documents and you can scroll through, at least you're giving Pink Floyd a fighting chance of coming to the attention of a human investigator and saying, why is that in here?
Yeah, and that's, I think that's why, we emphasize the augmented intelligence buzzword. I mean, we've got software that's chock full of artificial intelligence technology. I mean, it's funny, we're so shy about using that term that I've had, like I was on a call with a client once, and they were saying, God, we love BrainSpace. Have you ever thought of using artificial intelligence? And this is something you've been using like 8 different artificial intelligence tools, right? Because we emphasize so much that, this is about making attorneys, investigators more powerful. It's about augmenting their capabilities. It's not about the software going out and doing it on its own.
Yeah.
So.
And that whole uncomfortable discussion about how professional practice is going to change with these tools, and what practitioners are going to need to be good at and what they're going to need to be proficient with.
So what's your sense of that? Like, what's an investigator going to have to be good at, well, today and in 10 years maybe, to be somebody who's really maximizing value to whatever team, whatever client they have and whatnot with these tools?
Yeah, that's a good question.
Yeah, how about today?
We've talked about it more often in terms of lawyers and litigators, where a lot of these tools are automating it's like the Richard and Daniel Susskind talk about in Future of the Professions. There's certain types of professional tasks that can be automated or handled by technology, and they will be. But then the kinds of the parts of practice that are not going to be solved anytime soon, like creativity, interpersonal skills, persuasion, negotiation, things like that, those are going to be the kinds of things that the practitioners are going to have to do more of, because those are the things that the machines can't do. So you've got the human machine complementing each other, but that also means the nature of professional practice is going to shift. And just being diligent and knowing the law is not going to help you, because we've got QC tools and we've got research tools. So,
Right,
you know,
but I want to
that is
push you
where
on
the value is.
investigators,
Yeah.
not attorney. Everyone, you know,
Yeah.
it's clear that on the e-discovery, on the legal tech circuit, e-discovery's jumped the shark right now.
Yeah, well, to a
And so-
degree.
So it's all investigation.
I'll go for that, but to a degree, I think that the idea of diligence, you know, or just, you know, being dogged at going through stuff, just like
Okay.
being dogged at going through document review or going through all of the financial records, that isn't where the value is.
Okay.
It's gonna be the pattern recognition ability. The ability for someone to think creatively and say, if I were the person trying to embezzle funds out of this, how would I go about it? And then I can write up my synthetic seed and throw it in and see what comes back. And, you know, see how, well, you know, again, if we're talking about adversarial search, you have to be able to play that game, you know, and think about, well, what's my adversary trying to do? They're probably talking in code. Or maybe, as some other folks were talking about earlier today, they're sharing the same email account and they're both editing the same drafts. Or what else could I do to get around this stuff? And so the more creative thinking is what the investigators are going to have to be able to engage in, as well as, you know, as well as being able to spot irregularities. So if they see some, you know, this talk that we have about outlier detection, you know, everybody talks about, you know, but the important thing is whether it's an important outlier, whether it's meaningful. And somebody who has the domain expertise to spot and say, why is this person part of this conversation? You know, and to raise a red flag and then know to sort of pull on that thread and see what unravels.
Yeah.
Those are the kinds of skills that you're gonna have to have more of.
I think that's really good, because I think there is this kind of almost, it's a trope in the media about the dogged investigator. You know, even like the detective novels I read where the guys in their 12 hours a day going through the cold case file and looking at that, so that we're gonna have to get past that notion
Get a
that,
computer to do that.
that's right.
Yeah.
People should not be sort of doing this kind of mechanical sort of working. All right, well, we got the 5-minute warning, so I should, let me see if we've got other questions that have come up from this.
I know the answer to this question.
Okay.
So you talk about code, people using code. What about actual codes? Not like Enigma level codes, but people who are a little more clever than just having a catchphrase.
Well, I mean, I think the first thing you need to do is detect that, and that's pretty detectable. That is language, the statistical properties of language look really different than the statistical properties of encoded data. Now, there have been people who've done, you know, there's techniques that will take coded data and turn it into fake language. I haven't looked at whether that, my guess is even that's probably detectable. I think it probably doesn't look quite real enough. But then to break codes, I mean, that's a whole other issue, right? And it depends on how sophisticated it is. And
Fairly unsophisticated code that's just like every 50 of them.
Yeah, if it's unsophisticated, you know, I guess the question is, you know, it's unlikely to happen enough that you would build it into routine investigative analytics software. I mean, I'm sure the intelligence agencies would be the ones who do that. I mean, if you had to break a code, a dumb code that somebody just made up, I guess I'd go talk to the previous speaker and ask him to recommend a consulting firm, right? It's not the sort of thing.
It's not a kind of
It's not the sort of thing.
Or write some regular expressions and run that against your data or something like that. Yeah, but once you spot it, I guess. But
Other questions? All right, well, I was going to bring up another topic that I was going to actually play off a question of yours before, which are some of the risks of AI. So here's one that I worry about a lot as we're starting to, so we're working on some sort of sentiment analysis capability for the next version of Brainspace. There's been a big body of research the past 7-8 years in machine learning on bias in AI systems. And this is a huge topic. Once researchers started looking at this, they found, you know, I mean, the cases you hear about the most are, you know, if your company has been issuing loans in a racially discriminating manner over the years, and you train a machine learning system to decide who to make loans to, guess what? It'll be biased. But the problem is much, much worse than that. Almost any kind of training that you do, unless you explicitly take significant efforts to avoid being biased will be biased. And so one of the things that keeps me up at night is if I build a detector for detecting angry language in emails, is it going to hit some racial groups more than others just because of the particular slang that got used or particular aspects of my training set that I didn't even recognize were in there? And I think, we haven't had and I'm not sure we'll ever get this showing up in litigation, but I could imagine investigations, right? So suppose you've got automated,
Well, it's a big
yeah.
deal in criminal prosecutions now
Sure.
too, so
Yeah.
anything that could turn into a criminal matter, it's good.
Yeah.
You could see it in the case.
Yeah, yep, so all sorts of things that if you start turning over to a machine the responsibility for bringing particular people to attention to an investigator, because, really, you can't get in trouble unless you're brought to attention. Well, if you get brought to attention by an automated system and it's disproportionately bringing people of some protected class to the attention of investigators, you've got a real problem there. And so, that's one that we're just beginning to grapple with. Okay, I think we're getting the signal.
Yeah.
Thanks so much, everybody, for.